Hello, welcome back to my little series where we're making a little Pokemon-inspired game in Godot, at least the battle system, and we're also learning about game architecture too. This is video 5. If you haven't seen videos 1, 2, 3, or 4, this will probably not make too much sense, though there might be little tidbits. I don't know. I'm not your dad. You can do whatever you want. I will make a link to the playlist and put it up somewhere so you can get started where you're intended to, at the beginning. Last time we handled self-targeting and mischance for monster moves. We built a little heal effect and did a lot of cleanup and refactoring. Today, we're going to get into some really interesting stuff, less refactoring. First, we're going to figure out monster stats and how they play into your move damage, attack, defense, etc. Then we'll scope out a first draft of a combat flow system, making the opponent choose a random move, which is fine for now. Finally, we'll start building a simple condition system, which will let us have effects that can persist over time, such as a poison or an attack boost. Most of these will be using techniques we've been already discussing, but if you're rusty on the resource data pattern I cover in video 1, I recommend watching, or at least having a look at video 1 again. And we'll use a lot of getters and such to calculate things dynamically too. So think about that. Anyways, let's get started. Let's get started with monster stats. So if you recall, in Pokemon, monsters have a set of stats like attack, defense, special, and speed, as well as max hit points. We're going to add all of these except for special, which you could deal with yourself if you want. In later generations, it's special attack and special defense. Again, the logic for these should work more or less the same. You're just comparing them with different things. This will make our monsters and their move usage a bit more varied, since we can take into account monster stats to change attack damage, etc. And later on, we'll add level ups that will let us improve our stats incrementally. Let's open up monster and species and think about where stats should live. Well, it's a bit interesting because a stat is influenced both by a species but also by the individual monster. I think we'll put a base stat on the species, and later we'll have the monster calculate how its stat has grown, and we can take into account level and any other conditions, etc. We'll add some exports to our species for base hit points, attack, defense, and speed. And that should be all for here. And we can add anything else like special or special attack if you want. In Monster, let's update max HP to refer to base max HP. We'll also have to update the creation function to make sure it passes in the correct variable so that it doesn't cause any errors. Great, that seems to be working. Excellent. So note we've changed the name of the max HP exported variable, and this has actually reset all of our resources to have 0 max HP. This will happen if you change a variable name. So let's update the base stats on all of our guys. So Turtle can have a lot of hit points, bad attack, and very bad speed, but good defense. Salamander should be the opposite, low hit points, great attack, low defense, and pretty good speed. And we can give Dino kind of middle stats all the way through, and that's fine. Great, from here we can go to Monster and we can start implementing how we're going to access these values. So there's a very good reason we're going to use getters for this, and that's because stuff like level ups, conditions, and items might affect how these things are calculated, and we want a centralized place to access all of this, and we can use data to do that. We have a max HP getter already here, but let's copy this pattern and use that to get our various other values here. So I'm just going to paste this down here so they're all together, and we can make a attack one, a defense one, and a speed one. Let's keep it simple for now. What should we do with this now? We can use attack and defense now to calculate attack damage. So let's head over to dodamage.gd and we can create this calculation. So here we are. We're already making some calculations here for type advantage, but we probably want to involve our attack and defense calculation somewhere in this area here, affecting amount. So we'll probably add a utility function for this later, but we can do it right here while it's simple. So we probably want a multiplier that will express attack and defense difference. So we can make that here. I'm going to call it something like stat diff coefficient. And we can keep it pretty simple. You probably want a better function for this because this actually gets very overpowered if the difference is too high. So you probably want to think about how you might want to deal with this. Also, eagle-eyed observers will see a possible huge math problem with this implementation. Think about what might happen if we divide by certain numbers here. But we'll just stumble into that for fun and then fix it later. And then we just want to multiply by this. So in this case, if the attacker has the same attack as the defender's defense, it's going to be 1. And if the defender's defense is much lower than the attacker's attack, the damage will be increased. And you can figure out the rest there. Cool, let's just try this out. We're going to give Salamander a huge amount of attack, and let's see if he does a ton of damage. I'm going to play the game, and we'll see here. If we smack, we hit ourselves for 192 damage and kill ourselves, which is great. Exactly what we wanted. Smack is still self-targeting, at least in my version here. Anyways, let's reduce that, and let's see if we give Dino a huge defense and see if that reduces the damage. I'm giving him 67 defense here. And then if you fight and hit Smack, it still does damage to Salamander because it's self-targeting. But let's try one that actually tries to damage Dino. Torch, it does 0, so that's great. With a lot of defense, 0 damage, that kind of makes sense. We might want to clamp that, so you always do at least 1 damage. But yeah. I'm going to reset that there so we don't get confused later. Okay, what happens if Dino has a 0 defense? Well, that's a big problem because you can't divide by 0. It's an undefined operator here. So we need to do something about that. We can't promise that designers aren't going to set base defense to 0, or maybe some other code we do might give us a 0 defense at some point. So we really do need to make sure that defense can never go lower than 1, at least for this calculation. Easiest way to do that is just to use max, 1, and target defense. That means that if target defense is lower than 1, it will just be 1. And that's a quick operation we can do here that will save us from ever having to deal with a divide by 0, and also save us from a negative defense, because a negative defense will actually flip it and make it heal, which is also definitely a bug. That's a miss, and that's a 420 damage. Very nice. Perfect. What's next here? We'll deal with the speed a little bit later, but let's just do a dump out of our stats on the UI so we can see what they look like live. If we start the game, you can see that the log on the right-hand side is one of 3 tabs. We have a U tab and a them tab. I've included these so we can just dump monster stats out so we can read them without having to go into debug. Let's hook these up. The 2 tabs have the class monster data dump, and they should work the same as the monster renderer modules in that we can bind monsters to them and update them. In fact, we can really use most of the same code entirely. Let's just take the variable here for bound monster. We're going to use the same patterns here And yes, this is a little bit of code duplication, but it'll make it really clear to us in the future how this is supposed to work if we use the same patterns. So yeah, bound monster, we can copy and paste into monster data dump. It doesn't need to be exported because this is going to be something we change at runtime. Anyways, and we probably want most of the rest of this, right? Like connect events should be the same. We still want to listen to the same events. We want to maybe update the monster, maybe bind monster. And everything up to update here, including the first little clause in update, is going to be all the same because all we want to do is listen for stuff and then update this UI if it needs to be. Note we are missing a your POV variable here, so we probably need to add that. We definitely want to do the same thing. And that one is an export var. So we want to export a var, which is your POV, and it's going to be a Boolean. Terrific. Okay, cool. So I've changed it to your monster just to make it a little clearer because it's not really a POV, but that's exactly the same thing. I think Battle Renderer has access to these, and it does. And let's just, on this, we can call the connect events functions here. Great, so this way these will all be connected up and should get their events connected. Good. Back in here, make sure that you in the tree has your monster selected and save it. And let's go back to monster data dump. Okay, perfect. Update here is the only thing that's going to diverge from monster renderer module. So let's do some work here. All we really need to do is change the label text to whatever we want to show. And so if we play that here, let's see if we get the bound monster's name. Click on you, salamander, them, Steven. If that is showing up for you, it's basically working. All we need to do is give it a more interesting string to display. So let's do that. In monster here, we can think about how we might want to display that. Again, this might be another sort of getter or a function that functions like a getter. I think it's okay to have a function that has a little more stuff in it as long as you're not mutating any data. So this is going to be dump state. It's going to return a string. And we start by, well, let's create a variable called state string in here. And it's going to be a formatable string. And I'm just going to add some labels here. So like name, and then we're going to put name here. You can do /n to do a line break to break this up a bit. And then we can just start spilling out the various stats here. I'm going to do HP is going to be HP/max HP. And we do another line break again. Then we're going to handle attack, defense, and speed. And I'm going to speed things up a bit here because you can figure this out. I think you just follow the same pattern over and over again. Then we could put a slash here and do a dot format on the next line. And then we just need to provide the dictionary that has all of these values with the given keys. So name, HP, max HP, etc. You can figure this out too from the monster's variables. Great. And when that's all done, we can get back into the monster data dump, and label.text just has to be bound monster.dump state. And let's play the game again. And we can see that we have U is showing salamander with his stats, and them is showing Steven with his stats. Let's just make sure that that actually updates in real time. If we reset and we put the tab up before we use our move, we torch Steven, Brilliant. Monster stats work. We'll handle conditions pretty soon. But before we can test any conditions, we really need to give a structure to our turns and give the AI a very basic, very stupid behavior. We're going to implement turns in the wrong way first, at least the wrong way for Pokemon, and we'll come back later to make it a bit better. We're going to model this as an asynchronous process for now and create kind of phases for the game runner to go through. In this paradigm, the players have a turn order, and when they have a turn, they select the move for the current Pokemon to do. This is not how Pokemon works. In that game, both players choose moves. There's a speed test to see who uses their move first, and then the moves execute in that order. We're going to fix this in a video or two, but this is a little faster to implement, and I just want to get it running. Open up Game Runner. We're going to build out our little async phases here. They're just going to be represented by a Boolean, I think, for if it's the player's turn. First of all, we need to introduce a process function here. You've probably seen process before. It's one of the default functions that is overridden on a new node. Func process, it's going to take a delta time, but we don't actually care about the delta time because we're not going to use it. We can just put an underscore there so that we don't get a warning about it. And let's just toss a print inside of here to see that it's running and make sure I did not mess up this signature. Great. So as expected, process runs every frame. And that's fine. Okay, cool. Now let's add a little variable here to track whose turn it is. We'll add that variable in game state. This variable is going to not be used once we change the game to work like Pokemon, but we do need it for now, I believe. Now in process, we want to check if it's the player turn. And in the case of it being the player turn, we actually do nothing. Because if it's the player turn, we just want the process to run and we don't want to send any updates to the model until the player actually makes a change. So instead, let's flip it and say if it's not the player turn, then we're going to run the AI turn. What's the AI turn going to be? Well, we just need to make a new function for it. Let's go down to here at somewhere in Game Runner, and we can add our run AI turn. If you are building out a more complex AI or want to have a modular AI, we would probably put this in its own controller or have some more complicated behavior for it. Since this is going to be the only AI function we run for now, we're just going to throw it in Game Runner. And all it's going to do is, I guess, choose a random move. And there might be problems with this, but let's just type out the basics here. We'll do GameState opponent monster.moves.pick random. That should give a random move from that monster's list. Now, of course, that's probably going to break for various reasons, but we can get to those in a minute. We also want to check if the GameState.opponentMonster has moves. So I'm going to check for their size here. I get a little confused because I haven't written GDScript for a day or two and forgot the size function. And we can print something just to make sure that we know this is happening, because it's kind of a problem if the monster has no moves and we don't really have a struggle or anything set up for them to do. So we're going to have to do something about that. Anyways, if they do have moves, or at least if the moves array is bigger than 0, we can do something with that. Well, what do we do with that? So we have a random move from their array, and well, we should probably use the same code as we do for the player monster move, and that is to call use monster move at index. And monster move at index takes an integer, not a move, so we should probably swap to that, just so that things are consistent. Back in Game Runner, we're going to change this to, well, we can get an integer that is between 0 and the size of the monster moves array. Let's try that. That's going to give us an index. I'm just going to check here in the documentation to make sure that this is going to be exclusive. And it is not exclusive, so you could get the number, say 3, if you have only 2 values, because of 0 indexing, so we need to make sure it's size -1. Okay, cool. So now we have, well, this is a move index now. So let's see. We can try monster controller dot use monster move at index, and then we can get what? Well, we'll get the monster. And the index is going to be, well, this is going to be move index. Since this is Gen 1 and we're not doing double battles, we don't care about targeting. That's all controlled by the individual effects. You will have to figure out targeting if you're doing a more complicated game. And we could talk about that later, but that's not in the scope of this. Cool, so run AI turn should happen. We kind of have a problem where it will happen forever at this point. We probably need to flip the isPlayerTurn variable somewhere. Presumably, we can do that whenever a move happens, and later we can make sure it happens whenever a switch happens or a use an item or anything like that. So we could do that within our use move code here. We'll just make a new function here, like on turn ended, that we can add into Game Runner. And on turn ended, all it needs to do is swap isPlayerTurn using a not GameState isPlayerTurn. That should change the Boolean. Okay, so now whenever a move is used, presumably this should swap. Notice this will not happen if we return early, like in that move usages example up there, when it's 0. And it's also going to be a problem if the monster doesn't have any moves. Remember back in Game Runner there. So we'll have to do something about that too. But let's try this out first. We'll give Dino a move. 0 will fail everything, so let's give it smack here. And we can play the game again. And it looks like Steven uses smack, but it misses. So again, since the game has no animations to slow it down, it just runs everything instantly. But it looks like this is correct. The enemy is getting the first turn, it's doing its thing, and then we get a turn, and then it gets another turn after that. So that's correct, I believe. Excellent. Okay, we need to handle the issue of there being no usages for some moves. That's going to be a problem, and for a monster having null moves or an empty array of moves. So let's do that. So I think a better choice than just checking the monster move's size is to actually just get a list of indices that have legal moves from the monster, and then choosing a random one from that. And that can check for things like there being no usage points. So let's do that. I think that belongs probably in monster. And so in monster, let's give ourselves another function here. It could be a getter, but I think we'd have more room if we do a func. It's going to be an array of integers. Yeah, a getter, we'd be a little constrained for line usage. So let's just go with get legal move indices. Again, this is not a function that is doing any mutations on the data type. It's just going to be a glorified getter. So we're probably going to want to iterate over our moves here. I'm going to iterate using I rather than a for each, because what we care about is the index I. And then let's make a array here that we can assign stuff to. Make sure that we type it as an array of int. Each int is going to be 0, 1, 2, 3, an index of a legal move within this monster's move set. And then what we can do for each one here is check if that move has usages. And also, I guess, if it's null, because I suppose a monster could have a null move, though I'm not sure how. That would be an error in our data. But we should still check for it. So if moves I, well, if moves I should just check if it's null for us. So that's good. It will short circuit there. And then we just check if moves I has usages that are greater than 0. And then if that's the case, what do? We add I to legal indices. So if move 0 has usage, we can return it. We add it into our array, and then we go through the rest of all of the moves. Brilliant. And then we just return legal indices. That should make the editor happy. Yeah, okay, it makes me happy. In Game Runner now, what do we need? Well, we have to get a legal move indices array here from our monster. And that's angry because it needs to be run from the monster, but we can remove all this because we're going to handle that with legal move indices. We can do game state opponent monster dot get legal move indices. That should give us the list of legal moves. And then instead of this nonsense, we can just do legal move indices dot pick random. And we can check if legal move indices dot size is less than 0. If that's the case, well, what do? This is a case where they don't have any move that they can use at all. So here we need to, well, do something. Later we'll add a struggle move, I think, which is important to Pokemon so that battles don't soft lock. However, we can just add a on turn ended call here, which will end the turn, and we'll also emit a log just saying they don't have any moves, so it explains why nothing's happening. Tremendous. Okay, that seems to work, hopefully. Let's see. Okay, yeah. We can put this in else here. We also could have just returned from the end of that if. I think that would have been preferable, but this is how I decided to code it, I guess. Hindsight. Anyways, so if legal moves is 0 in size, they can't move, so we end their turn. Otherwise, we grab a random legal move, and then we use it. Let's run the game and see what happens. It looks like it is working just fine. Very cool. What's going to happen here if we remove Steven's move, though? Is it going to crash, or is it going to say that he is not able to act? Let's see. Go to Dino. We'll remove Smack. We'll just clear it out so it's a null. And then we run this, and what happens? I think it's going to break. Yep. Okay, so we're trying to check usage max on a null resource here. What's up with that? Oh, we're trying to create a monster this isn't the create monster code. If the move resource is null, it cannot set a usage max. So let's just continue. A continue operator will send us to the top of the loop, in theory. Oh, we can't do is null. It has to be equals null. Yeah, okay. Thanks, GDScript. Let's run this again and see what happens. Okay, so can't act, no moves, that's correct. If we smack, Salamander does a thing, but Steven can't act. That, I think, is correct behavior. Perfect. Okay, cool. The last thing I want to handle here before we move on is now that we have artificial, air quotes, intelligence, we can add speed in and check monster's speed to determine turn order. The way I'm going to do it is a bit half-assed, and we're going to return fairly soon to actually make this work like Pokemon. So I'm just going to check in setup here to see which monster has higher speed and set the turn based on that. I realize it's not actually going to work if you swap monsters. It'll just keep that turn order. But I don't care because we're changing this really soon anyways. Yeah. So let's just game state is player turn equals game state dot player monster dot speed is greater or equal to, and I'll just give the player the advantage here. Why not? I think Pokemon flips a coin for it. 50% chance if they have equal speed. And we can check that. Very cool. If it's not super clear from this, I actually haven't played Gen 1 Pokemon for a few years, so I'm just kind of doing it from memory. While making this series, I watched a lot of videos from J-Rose doing challenge runs, and I learned a lot and actually start figuring out things I need to change as we go on. Anyways, I swapped Pokemon around to check if speed is working correctly here, and it looks like it's fine. Okay, cool. This AI loop is not going to win any awards, but I mean, in early Pokemon, a lot of the trainers are just using random moves, and I definitely think the wild monsters tend to use just random moves. We're going to do another iteration of this pretty soon because it is pretty rough, but I think it's enough for us to move on and get conditions working soon, so thank you. Great, the next thing we want to do is to handle conditions. Conditions need to have some sort of data class as well as a resource class, so we're going to reuse the same pattern we used for monsters. Check out the first video for another explanation of this in a bit more depth, but basically all information and functionality general to a condition is going to live on a resource, and then instance data specific to an application of that condition is going to be in a data class. Think of the difference between the idea of poison and the poison that is on your Pikachu or whatever. Anyways, it's time to create both of those. I'm making a condition resource in scripts content. And we want to make sure it has a class name, condition resource, and it extends resource. Great. Let's give it an expert var name. String works. Just a string. And that's a good start for now. Now let's create a new condition in our content. So let's go to content, dot in scripts, and then let's make a new folder called conditions. And inside conditions, we can make a new condition. It'll be a resource, condition resource, and we can call it poison. Double click on that to open it in the inspector panel, and you can give it a name. Let's just call it poison here. Cool. Okay, well, this doesn't really do anything yet, but we do have the idea of a condition resource now. Let's make let's make our data type for our condition. Let's make another condition here. It's going to be a attack up condition, sort of like sword stance. I'm calling it knife dance, but I think let's rename it to attack boost so it can be generic, so different moves can have it and it will overwrite itself maybe in the future. I'll just call it attack boost in here. Wonderful. Okay, we've got two conditions sitting here in content. What do we want to do with them? Well, we first have to create our data type for conditions. So in script data, let's create a new script. This is going to be condition.gd. And it is a data type. It doesn't need to extend node at all because we're not going to add it to the scene tree, but it will have a class name of condition. Okay, cool. What does condition get in it? First variable, we don't need to export it, of course. It's going to be var resource, and that's going to be a condition resource. Every condition points to the resource that it's implementing. This is going to be the poison that's on Pikachu. It has to point to the poison resource. Cool. Let's add a name variable. It's going to be a getter, which we've done several times before. So we can just do var name string and get, we can just return the resource.name. Great. Now we have a data type for our condition. But how do we add a condition to a monster? Let's make sure a monster is able to have conditions. in the monster.gd data type here, we can look through here and we see we don't have any, we don't have a field for this yet. So we'll do var conditions array condition, not condition resource, condition. Great. Okay, so that's going to work. We need to be able to add things to this array, and it will just be the active conditions that are on the monster. If a condition is removed from this, we will say that it is no longer an active condition. How do we add this though? I think since we do all of our mutations in controllers, it's probably going to be in our monster controller. If you really wanted to, you could have a condition controller too, but I don't know. And in order to attach it to a move, let's create a new targeted effect. It will be add condition.gd. And that's where we're going to target the condition from. So let's copy some code from do damage. We basically need the do function. It has to be the same because it's also going to be extending the same targeted effect, and it has to essentially have the same shape of function, so we can use do there too. Remember, class name add condition extends targeted effect. Anyways, what do we do with this do here? So we're going to add a condition. First, we kind of need a target. I think we can just copy the target code from do damage, and that'll work fine. Now we have a target. What do we do with this target though? Well, we're going to have to call something to add a condition. For now though, let's just create a new move that's going to have this add condition on it so we can test it. Let's make a new move resource. This is going to be called Knife Dance. It will be a self-targeting attack boost similar to Swords Dance, but I guess a little bit smaller and more appropriate at a Persian wedding. And then in use effects, you can put size of 1 and then put add condition. If it's not showing up there, make sure it is extending targeted effect. I'm going to say it happens on both hit or miss. Yep. Base accuracy, I want to always happen, and then type normal is fine. That works fine, I think. Okay. Now what do we do? Well, let's add in add condition a reference to a condition resource so that we can add that condition. So make sure that it is export var condition resource that shows up there, and then we can quick load attack boost. Great. Now that should be applied once we fix it all up and hook it all up. It should apply attack boost to the user's mon. I'm adding Knife Dance to Salamander's moves. And let's just see if this works. It's not going to actually do anything because we're not actually setting the condition to be added yet. In Game Runner, let's figure that out. Oh, I had the wrong mon as mine there. It was the turtle, so I just had to swap that. Anyways, we can use Knife Dance and it doesn't cause any problems. But it doesn't do anything yet, and that's okay because we have not set it up. Okay, cool. Doesn't crash. That's good enough for now. Let's clean things up a bit. We can close the other stuff that we're not using. And, well, we need to do some sort of call here that says I want to create a new condition and add it to our monster target here. So I'm making a little note of that so that I can work on that. I do say create a move from the resource, but it should be create a condition. Oops. Okay, cool. So what do we do here? Well, I mentioned before, or I may have mentioned before, depending on how I edit this, we want to do all of our stuff on a controller, and monster controller makes sense because I do not want to make a condition controller because all conditions are related to monsters, at least right now. Anyways, if things get more complicated and conditions become a really complex functional thing, you could split it off into a condition controller. Anyways, we'll have func instantiate condition on monster that takes a monster and a condition resource. And what's this going to do? Well, we're going to make a new condition, and then we're going to put it in the monster's condition array. So let's just return for now, so we can just pipe that out from our do function here. Monster controller dot instantiate condition on monster to the target and with the condition resource. Okay, well, that should do something. I mean, nothing yet, but it could. Let's add our functionality here finally. Okay, so what do we do? We're going to create a new condition, so that can be condition.new. And then condition.resource is going to be condition resource. And what do we want to do now? We just want to add that to the monster's condition array. Monster.conditions.append condition. Okay, cool. Now the monster has the condition. Simple as pie, I believe. Not that the condition is going to do anything yet, but we can work on that next. Let's just put a breakpoint here and check if the monster is receiving the condition. Okay, fight, knife dance, and it looks like if we click on monster here, we can see that it has conditions, area of size 1, and it is the attack boost. So that is the correct behavior as far as we know. Okay, what does attack boost do though? Right now it's just a name. So let's look at our condition resource again. Right now it's just a string name. And I think we need something that is a type that expresses a stat modifier and a stat. So let's invent that type. We can make a new type that will be able to say something like attack +5 or defense -6. Let's go to script/content, and we're going to create new script. The script is going to be called statmodifier.gd. And it's going to have two very specific things in it. One, a reference to the stat we're modifying, and two, the amount we're modifying that stat. So let's do export. Well, what are we exporting here? What's the stat modifier? I think we need to have some sort of enum for this. So let's go to scripts util. We'll create a new script. We'll call this stat. And inside of it, we can get rid of extends node because this is just going to be a static type with an enum. We'll do class name stat. And then inside stat, we want an enum called code, which will have things like attack, defense, spd, max HP. And we can add more later, or you can add special if you want. Anyways, let's now make a reference to that. We can do export var stat is a stat.code, and then export var modifier is going to be an int. And if you want to do multiplicative modifiers, you'll have to do a float probably, or should do a float, but we're just going to do sum for here. Export var stat modifiers is going to be an array of stat modifier. Okay, cool. So now in our condition resource, we should be able to add stat modifiers. So in attack boost, let's add 1 and then a new stat modifier. We're going to do this right here rather than creating a resource outside, which would let us reuse a stat modifier, but since these are fairly local and non-repeating, we can just create one in here. That way it will live just inside of our attack boost. It's going to have attack, and the modifier is going to be 5. And if we did -5, it would be a debuff. Now, how do our modifiers that we're creating here actually interact with the monsters? Because this is still not going to do anything with anything that we have set up yet. Let's go to our getters within our monster.gd script. And this is another thing that is powerful about getters, is we can do a little bit of logic here. And the logic we want to do is just sum up all of the modifiers that are currently on our monster. So let's make a little function here that can help us sum things up. We'll say sum condition stats for code. And there's probably a way to do this with a fancy one-liner, but those are really hard to read. So we're just going to make a little double loop. Double loops should be, you should do them carefully, because if you put a lot of things inside of those loops, it could be a big performance issue. But since there's probably only going to be 3 or 4 max conditions on a monster with maybe 1 or 2 stat modifiers each, this is really only going to happen a few times. So I don't think it's a concern. We'll start sum, var sum equals 0. We'll do for condition in conditions, and then for modifier in condition resource stat modifiers. What do we do with this? We're just going to say sum plus equals the modifier's modifier. And we'll just call this stat modifier so it is a little bit clearer. Notice we are missing something important here, and that's checking if the stat code matches, but we will get to that in a second. We do want to try this out though. And how can we do that? In monster here, we also want to use this now. So let's add this to our getters here. We can just put a plus and then do some conditions for stat. And then stat code and make sure it's the right one. This is not the right one, but I'm just going to copy paste them and then edit. Some conditions for stat. We want this to be, first one is max HP for me. You can organize this however you like. Attack is great for this one. This one's def, I believe, and then spud. Super, okay. Looks like the condition's appended, and that should work. Let's do a little test. Actually, first, before we do a test, let's emit our onMonster updated so that we can see the changes happening. This will update our monster stat dump that we did last time. So have a look at our stat here, and if we hit knife dance, all of our stats go up, which is a bug. It's actually kind of a bug that is in first gen Pokemon too, if you've got the badges, but it is a bug we are going to fix here. Let's, in here, we just need to check if stat modifier code equals code. Because if we are seeing things that are increasing speed, we shouldn't be increasing attack also. A little more nesting than is aesthetically pleasing, but I don't think this is actually going to be an issue because of the scale of our data. Okay, cool. If we knife dance, we see that our attack is big and it gets bigger and bigger. Now, we probably want to clamp this somehow. But that seems to be working. And let's see, if we hit for a ton of damage, even if it's not effective. So I think we are actually now listening to the stats. So that's excellent. Stats can grow massively now. And if we have a debuff stat, which we can try, they'll also probably let you go negative. And that's probably going to be a big problem because negative attack, for instance, could make it so you're healing the enemy monster, and that's a little bit silly. Let's see. So if I am debuffing myself here, if we have -5 attack and then we use something, well, we heal them. We're already clamping hit points, so it's not a problem here, but that's kind of a funky interaction that we don't want. So I think we need to do something with clamping our stats. So there's an easy way to do it. It's a simple function in Godot. All you have to do is return clamp. And then the clamp takes 3 values. You can put in the actual value, the minimum, and the maximum. And that way, If this is below the minimum, it becomes the minimum. If it's above the maximum, it becomes the maximum, and otherwise returns the given value. So I'm just going to clamp everything here between 1 and 99. We may want to change this later depending on how we're scaling values in the game. Maybe 999 is a normal mid-game value for your crazy big numbers idle game. I don't know. But for now, I think 999 is fine, I guess. We'll come back to that, or not. Now let's see if I make it a debuff and I go back into the game. Let's see if we hit Knife Dance once, we go to 2. If we hit Knife Dance again, we stay at 1, and that is great. Okay, I'm not going to test the 999 limit, but I think it's going to work fine. Clamp is a pretty handy and predictable function. Killer. Also, this saves us from having zeros, which could also cause problems if we're dividing by anything. Okay. Yeah, and I mean, this looks a little repetitive, but I think we might want to later refactor that into a calculation function in utils, but we can do that. Okay, we can handle things like stacking and overwriting and condition durations next time, but for now, I want to make sure we add conditions to the dump state for the monster so we can see which ones are affecting each monster. So we're going to go to our monster and let's add to our dump state thing here. I'm going to add a conditions variable and make sure I add it to the format string too. And what does the conditions look like? I'm going to try a couple things here. So if we start it as a string, we could maybe parse through each condition and add the name. We can do condition string plus equals, the condition.name. And then I'm thinking maybe there's like a join function in GD script. I look up string here, string join. I start thinking maybe I can just make an array of all the strings I want to add up here. So let's think about that. Condition string. No, let's make it an array. An array called condition names, I think. And for each condition, we can append the name from the condition. This is starting to look a little woolly to me. And then we can do condition string equals, I think, like string join. I don't know if this is a static function. It should be. And if I run this, and this should be condition string. We can't call a non-static function join on string directly. We get an instance instead. And then I kind of get tired of this and I think, let's just build it off of concatenations anyways, because it'll be fine. This is just a debug feature anyways. It doesn't have to be special and beautiful. I'm a little tired at this point, so I'm not going to try to do this perfectly. But let's do that. We'll put a little space in between each one, and then we can just return the condition string. That should be fine, I guess. I'm not going to win any code awards with that one. Okay, and conditions. Okay, attack boost is still on the same line as conditions, so let's probably fix that too. You can do whatever you want with this. It's not that important, but I want to look at least readable, if not good. Well, maybe not good, but good enough. Okay, now all the conditions go after this. There's a space there, but I'm just not going to care too much about that. I think it's fine, and it shows us what we need. Anyways, I think that's enough for the very basics of conditions. We're going to come back at this and do a lot more complicated stuff. You'll see we can use conditions for a ton of stuff, so can't wait. Well, all right, that was fun, wasn't it? I had fun. I hope you had fun too. We have now got conditions. We can apply them. Our monsters have stats. Our enemies can fight back a little bit. So this is actually starting to shape up into almost a little bit of a game, though we've still got a long way to go. Next video, we're going to improve our conditions so that they can trigger effects, such as doing damage to you every turn or that kind of thing. We'll also deal with condition stacking or overwriting. There's lots of ways you can go with that. We'll discuss a few, as well as condition expiring with a duration. I don't really remember if first generation Pokemon does that. I think it does for some conditions, but you can do it however you like. Then we're going to rewrite the game flow because when I made this video, I had forgotten how Pokemon turn order went. And in the next one, I actually will implement something much more similar, which will also make it very easy to implement both speed checking per turn, as well as fast moves like quick attack, which will take priority over others. Then we will handle some more game structure stuff, such as checking for monster fainting, swapping monsters out if they faint, and triggering some sort of win or lose condition. So keep your eyes open for that. It's gonna be hot. Okay, I'll see you soon. Like, subscribe, do whatever. This is a brand new channel. I'm trying to become more popular than Wayne Gretzky. So I've got a ways to go. Goodbye.